The value in any numeric type can be assigned to any other numeric type. Java will convert the values as necessary, but sometimes you may have to force it. When you force a number to fit, even though you may lose some of the value, that's called narrowing. For example, if you store an int value into a short, you are narrowing the value. Some will fit just fine, but other values will just be chopped off. There's no way that the Java compiler can tell ahead of time whether the value is going to fit. But you can force it. You force it by casting. You cast a value by forcing the conversion to another type by specifying the type in parentheses before you execute the assignment. This statement is casting B to a short data type. Whatever data type B actually is, its value is converted to a short data type before being assigned into A. You can always cast a value before you assign it, but it isn't always necessary. In this example, if B is a byte, there is no need to cast it before you assign it to a short variable because the compiler can tell that it will always fit. You don't always need to cast to bring about a conversion. For example, in this statement, if A is an int and B is a short, there's no need to cast because every possible value of B will fit into A. This is known as widening. There is no need for casting to widen a value. I've written a small program that demonstrates some of these conversions. This program starts with a byte value and uses a series of assignment statements to cast it up to a short, a char, an int, a long, and a double. Then it reverses the process and assigns it all the way back down through each type again. As long as there is no possibility of loss of precision, there is no need for casting. If there is a possibility of loss of precision, the compiler refuses to compile the statement until you include casting. This means that while you need to know about casting so you can use it when you need it, there is no need to do it until you're certain. If you don't cast something that you should have, the compiler will mention it to you and refuse to compile it. The result is that when you look at a line of code, the fact that casting is included as part of the statement notifies you that there is a possibility of loss of precision. The compiler won't do anything that could lose information inside an expression unless you force it to do it. Notice here that this particular value is small enough that it doesn't change. You might want to try this program with larger values and see how the values get chopped off when you cast it to a narrower type.